This is lecture 7 from chapter 9, and we are back with naming chemical compounds. And I decided to go ahead and pick up here. So I showed you this compound with potassium, manganese, and oxygen. What I wanted to do is do one other example out of our other ones down here, one without a polyatomic ion. So let's take a look what we've got here. Let's do the first one there on the list. So we've got our friend potassium again. So we saw that one earlier. So we know potassium is in group 1. That's a +1 ion. The other one was sulfur. So sulfur is over here in the group with oxygen. So it is in group 6. So that means that it has 6 outer electrons. It's missing 2. So it's going to make a -2. So let me grab my pen. So we've got potassium with its +1, and we've got sulfur, and we know it makes a -2 ion. So same as we've done before, we're going to swap these guys' locations. So when we rewrite it, we're going to say K gets the 2 to balance out the sulfur, and sulfur would get a 1 because of the 1 charge on the potassium. And so the formula for this ionic compound would be K2S. So like I said, the other formulas will be in the notes section on the PowerPoint. So give those other ones a try using your periodic table. And I'm going to go ahead and move on to naming covalent compounds. Now, I'm not going to ask you to name any covalent compound. I'm only going to ask you to name binary covalent compounds, meaning covalent compounds that contain 2 elements. The covalent compounds that have more than 2 elements, their names get complicated, and we're not going to get into naming those in this class. So we're going to start with naming covalent compounds with the element with the lowest family number first. So if we go back into our periodic table, remember that covalent compounds are going to be they're going to be non-metals. So this is why we go with the lowest family number. So if carbon is in it, carbon's going to be first. If nitrogen is in it, nitrogen's going to be first. So you're going to go with the lowest family number as the first element in your binary covalent compound. Now, the first element in the formula is named first with a prefix indicating the number of atoms greater than 1. So what do I mean by this? Well, if you only have 1 atom of that element, so if you only have, say, 1 carbon atom, then you're just going to say carbon. But if there's more than 1 carbon atom, so say there are 2 carbon atoms, you're going to have to put a prefix on it. So you're going to have to put a di in front of that carbon, so dicarbon. The di indicates the 2 that would go in the formula if then we were writing the formula from the name. And I'll show you an example of that once we get done with our covalent compound name rules here. The name of the second element is going to end with "ide," so that we call that the stem name. So that would be like bromide. So the element is bromine. So we're going to take the first part, the stem name, brom, and then stick "ide" on the end of it in order to make that second element name. And we're going to put a prefix on this one if, again, you've got, well, prefix is used if 2 elements form more than 1 compound. So not if we've got more than one atom, but if we've got more than one option for this compound. So examples of this would be, for example, you've got CO and you can have CO2. So this is why we have carbon monoxide and carbon dioxide, because both of these compounds exist. They both contain carbon, they both contain oxygen, so we need to put a prefix on the oxygen for this compound so that we know that there are two. If there's only one option for a compound, then it won't have the prefix on the second element, because that's the only option that you've got for the bonds that can be made. So here are the different prefixes that you'll see. So mono for one, you'll only see mono used if it's something like what we just saw with carbon monoxide. So there's more than one option. Di for two, tri for three, tetra for four, penta for five, hexa for six. Generally, for what we work with in this class, we don't generally go above six, but you may see the other ones. So hepta for seven, octa for eight, nona for nine, and deca for 10. These are just to give you examples of some of those stem names. So most of these you've probably heard with the ides on the end. So hydride, carbide, nitride, oxide. Oxide's a pretty popular one. Fluoride, phosphide. We don't usually do phosphide. It's usually with the polyatomic ion phosphate. Sulfide, we do have sulfides, chlorides, bromides, and iodides. So that's what we mean by the stem name. The stem name is what we are going to add that ide to. So let's try a little bit of practice. So what would we call the following compounds? Now, I wouldn't expect you to know necessarily that there are multiple versions of one of these compounds. So to be on the safe side for that second element, go ahead and put prefixes on any of the elements, because, unless it's one you know for sure. So we've done this one, so that's carbon monoxide. So we've got mono for the single carbon that's there. And then we saw this one, carbon dioxide. You get to see my very nice writing with my computer pen. There we go. So monoxide, dioxide, okay, for these guys. So let's take a look at this one. You might not know this element off the top of your head, so you might need to take a look at your periodic table. So go ahead and take a look. In fact, let's flip over there. So you're looking for B, and there it is. So B is boron. So take a look. Okay, and we've seen F for fluorine. So we've got boron and fluorine. So it would be boron fluoride. But we're not sure if there's more than one option for this. So just to be safe, go ahead and name it boron trifluoride. So that's what I was talking about as far as on this second one. If you're not 100% sure, just go ahead and put that prefix on the second element. So here's an example of one that has a prefix on the first element because it's got a subscript to show a number. So this one would be dinitrogen. So you don't add anything else, it would just be the prefix. So dinitrogen, tetraoxide. So tetra for the 4 and then oxide for the oxygen. And I'll have these typed out in the notes section so that you can see what they look like written out. And then this one, you know the common name for, and some of these other ones have common names too. But you know this one is water, but go ahead and try naming that one as its actual chemical name. Okay. All right, so then how do you write covalent compound formulas from their name? Well, the nice thing is that generally their name is going to tell you exactly what's in the formula. So it's going to tell you what the number is for each element if you know the prefixes. So if you're familiar with mono, di, and so on. For that first element, if it doesn't have a prefix on it, you assume that it is 1. So dinitrogen monoxide. So di would be for 2, right? We know mono is 1. So what we're looking at is nitrogen, 2, and oxygen. So dinitrogen monoxide. So, so nitrogen dioxide. So this is the kind of the flip. So this one would be nitrogen, no prefix, so that would just be 1 nitrogen. And di for 2, so we know that this one would be O2. And so you can see why having those prefixes on the second one is very helpful, because this is actually 2 versions of a compound where, yeah, the dinitrogen's different, but you also have different versions of the oxide. Carbon tetrafluoride, go ahead and give that one a try on your own. Oop. And that is the end of the lecture. So this is the end of chapter 9. And if you have any questions, as always, let me know. If you need some extra practice, I can point you to some websites for some extra practice on building chemical formulas, naming chemical formulas, and working on those ionic and covalent bonds.